Hello ladies and gentlemen, today what we're going to go through is just through a third way to solve a system of equations. We call this elimination. Alright, another name for this is called a linear combination. Here, any of those, that's what we're talking about. Now again, when solving a system of equations, the solution to a system of equations is where the two lines intersect. That doesn't change. Alright, we're still trying to, if you graph the two lines, we're looking for the x and y coordinate where these two intersect. That does not change no matter what we're doing here. Now, when we talk about elimination, the reason why we have this is because of the type of equation you're going to look at. When we look at this, you're going to look at linear equations that are in standard form. We've talked about it before. We'll go over it again. This is ax plus by is equal to c. A, b, and c are all integers. Now you can pause it for a second, and I want you to take a look. You can look at the different examples. Right? These are all examples of linear equations in standard form. Right? So pause it, you can look at it, but I'm going to continue on. Alright, so the first type, when we look at this, the idea of elimination is basically what its namesake is. We want to try to eliminate a variable. From what we've talked about in the past, you cannot solve an equation with two different types of variables. That top equation, you cannot solve it right now because it has an x and a y in it. Right? You know how to solve an equation with one type of variable in it. Right? So what we're going to do, knowing that these two equations are working together to find the same point, we're going to manipulate these equations into one equation with one type of variable. Kind of like what we do with substitution, just slightly different. The first thing that you're going to look for is, are these in standard form? Right? Ax plus by is equal to c. Right? And as you can tell, these are in standard form. After you know they're in standard form, what we're going to do is we're going to draw a line underneath them. Now, knowing that these two equations are working together, we know that the x coordinates are the same, the y coordinates are the same. What we can do is we can combine them into one equation. By combining them, what that means, you have to combine like terms. So what we're going to do is we're going to basically add straight down. X plus 3x is 4x. 2y and a negative 2y gives you 0y. And 7 and a negative 3 is 4. Now, one of the things I want you to notice, at this point in time, you've eliminated a variable. How do you know? Well, 0 times y is 0. It's gone. All you have left is just 4x is equal to 4. You're down to one type of variable now, just the x. You can solve this one-step equation. Divide both sides by 4, x equals 1. So what you have now, just like before, is you now have the x coordinate. We still need to find the y coordinate. This is no different than what you did with substitution. Once you know what the value of a variable is, you can plug it right back into either equation. It does not matter which one. I personally would choose the first one. I would plug the 1 in for x. So I'd write a 1 plus 2y equals 7. At this point, you just solve it like a lovely little two-step equation. Add negative 1 to both sides. That's 0. So you get 2y is equal to 6. Divide both sides by 2. And y is now 3. So, if you were to graph these two lines, they would intersect at the point 1, 3. Alright, we're going to move on. Next one. X plus 6y is equal to 48. And negative x plus y is equal to 8. First step in solving a system of equations using elimination. Are the equations in standard form? Do they look like ax plus by is equal to c? As you can tell, they do. Knowing that, we're going to draw a line underneath. And the reason for that line is to show that we are going to combine these by adding straight down. So we're going to add. X and negative x is 0. 6y plus y is 7y. And then 48 plus 8, 56. Hopefully you've noticed at this point, you have eliminated x. X is gone. 0 times x is 0, so it's gone. all you'll have left is just 7y equals 56. You can solve that because you have one type of variable. So you would divide both sides by 7. Y is equal to 8. At this point, you have your y coordinate. We still need to find the x. And again, it does not matter which equation you choose. I'm going to choose the first one, but you can choose the second one. Right. The second one will work just fine. When I plug this in, x plus 6 times y, which is now an 8, equals 48. No? 6 times 8 is, I'm sorry, 48. And when you add negative 48 to both sides, to get x by itself, that's 0. 48 minus 48 is 0. These two lines are going to cross at 0, 8. So what you're going to find out, if you put these in slope-intercept form, I bet you'd find out their y-intercepts are all 8. Alright, next one. Negative 7x plus 9y is equal to 57. Then 7x minus 10y is equal to negative 68. Same idea. We're again trying to eliminate a variable so that we can solve an equation. Right? So as we look at this, are they in standard form? Yes, they are. So from there, we add straight down. Negative 7x plus 7x, well, that gives you 0. Okay. 9y and a negative 10y, that's a negative 1y. And then negative 68 and 57, this should give you a negative 11. Right. From there, you look. 0 times x is 0, it's gone. But we still have this negative y is equal to negative 11. That's like a negative 1, so we have to divide both sides by negative 1 to get y is equal to 11. We now have y, we still need to find x. So at this point, you got to pick whichever equation you want to plug this into. I'm going to plug this one into the second equation. You could use the first equation, you'll still get the same answer. But I'm going to use the second one. 7x minus 10 times 11, which was y, equals negative 68. So at this point, 7x times a negative 110 equals negative 68. And then from there, two-step equation. Add the opposite of the negative 110, which is 110. That's 0, so you get 7x. And again, if you need to do this by hand or you can use your calculator, you can. 242. There you go. So negative 68 plus 110 is 42. And then, make it real simple. Divide both sides by 7. And x equals 6. So, again, if you graph these two lines, they would intersect at the point 6, 11. Alright. Last one. As you look at this one, first rule again, are the equations in slope are in standard form. Ax plus by is equal to c. And I bet you some of you guys are going to notice that the second one is not. Now how you do this is going to be kind of up to you, but I want you to kind of get in a habit. I'm actually going to rewrite the first one. I'm going to rewrite the first one because that one is in standard form. Then I'm going to look at the next one and think what has to come first. Well, the negative x has to come first. Then the plus 8y, and then the negative 16. Then I'll draw my line. I do that especially for what you guys are going to do on the next two lessons. All right. And you'll see that you're going to do that quite a bit on those anyway. So just get in the habit of doing that. Now, as you look, they're in standard form, so we're going to add straight down. 3x and a negative x is 2x. Negative 8 plus 8 gives you 0, so we get 0y. And 32 minus 16 is 16. You notice now that you've eliminated y. 0 times y is 0. So you have 2x is equal to 16. You can solve that one-step equation by dividing both sides by 2. And you get x is equal to 8. So the x coordinate at this point will be 8. We still need to find the y coordinate. And from here, it's up to you which equation you want to substitute this in for. I would probably use the second one. When you go to plug it in, always use your original equations. That'll definitely help you out once you get into some of the tougher problems. So when I write this, 8y, and then the opposite of x, which is now an 8, so it's negative 8, equals negative 16. Two-step equation. Anything being added or subtracted as a variable, you're going to move first. So you're going to add the opposite of the 8 to both sides. That's 0, so you get 8y is equal to negative 8. Divide both sides by 8. Y equals negative 1. So now, if you graph these two lines, they would intersect at the point 8, negative 1. Alright, so as we look at this, that's the very first idea of solving a system of equations using elimination. For the most part, not too tough. On the next couple lessons, we're going to add in some steps dealing with different types of situations. But if you can add straight down and eliminate a variable, that's great. You move on from there, and we'll talk about some of the other ones. Alright, you guys. Have a good day. Bye.